control. Oh my gosh. Goodness gracious me. Okay, that was a little bit of tidbit on asteroids. Now we will get a little tidbit on comets. Unbelievable. Near, far, wherever you are, I believe that the heart does go on. My stream has not gotten derailed. Which noise? Once more, you open the door. And you're here in my heart, and my heart will go on and on. Is the door wrong? Can we get 20 likes? Alien, can you please like the live? 20 likes, come on! When we observe the asteroid belt, we can directly detect asteroids down to a size limit of 1 kilometer. This is about comets now. We can deduce indirectly that smaller bodies exist in the asteroid belt because of the impact craters they create on larger asteroids. When we observe the Kuiper belt, because of its much greater distance, we can detect only TNOs larger than D equals 30 kilometers. Nevertheless, we have good reason to believe that smaller icy objects exist in trans Neptunian space. Imagine an icy body around 1 kilometer across in the Kuiper belt. If we moved such a body toward the inner solar system, then once it was within 4 astronomical units of the sun, its ices would start to sublime. So as we know, when you get closer to the sun, it gets hotter, things will sublime, such as even methane, right? The resulting gases would form a large tenuous atmosphere or comma that would be more easily visible than the tiny ice ball at its center. In fact, we have just described the behavior of a comet. The nucleus of a comet is an icy planetesimal. Remember, we talked about planetesimals when we talked about planet formation period from the nebula that we all come from. But the nucleus of a comet is an icy planetesimal left over from the formation of the solar system. So they're as old as the formation of the solar system. Typical cometary nuclei are between 1 to 10 kilometers across and have a mass of around 10 to 100 billion tons. So quite massive, but you know, cometary nuclei are often described as dirty snowballs. Dirty snowballs. Since they consist of loosely packed ices mixed with rocky material, spacecrafts have been sent to rendezvous with Comet Halley and with Comet Tempel. Both these comets have nuclei that are cratered and irregular in shape. Their densities are quite low, as in 300 kilograms per meter cubed, indicating that the nuclei must be very loosely packed snowballs indeed. The surfaces have low albedos, so not very reflective. The sublimation of ices has left a surface layer